In Chapter 6, we're only going to cover Section 6.4 and 6.5. That's about rational functions and applications of rational functions. So Section 6.4 is about equations of rational expressions and their graphs. So a rational function is defined by a quotient, i.e. a fraction, of polynomials, and it has the form f of x equals p of x over q of x, where q of x doesn't equal 0. And the domain of this rational function is all real numbers except those that would make our denominator function equal to 0. And this is because we cannot divide by 0. So one thing we need to be really certain of when we're working with rational functions is defining our domain. So how do I give the domain of a rational function? So the first thing we want to do is remember what a domain is. So the domain is the set of all possible x values that a function can have. And since our denominator cannot be 0, if we set the denominator equal to 0, that allows us to define what values should be excluded. So our first step is going to be to factor the denominator, right, using all of our factoring skills we learned in Chapter 5. Then we're going to set it equal to 0 and solve for the points, i.e. the x values, not included in our domain. Then we want to write that in set or interval notation. So let's look at equation 1. So here I have the rational function f of x equals 5 over 3x plus 2. So I'm going to take my denominator, which I cannot factor any further, and I'm just going to go ahead and set that equal to 0, and then I'm going to solve. I subtract 2 from both sides. I get 3x equals negative 2. I divide both sides by 3, and I get x equals negative 2/3. So x equals negative 2/3 is the value that's excluded from my denominator. If I was to substitute this x value back in, my denominator would be equal to 0, which cannot happen, right? We cannot divide by 0. So I can write this in set notation. X such that, remember this bar means such that, x doesn't equal negative 2/3. I might want to label that as our domain. Or I could write it as interval notation. How would I start writing it in interval notation? Well, I always like to sketch a little number line, not a pretty one. And I say, okay, my graph, my domain can be any x value except negative 2/3. So if I go to negative 2/3, there's going to be a hole there. But it includes everything else. Everything else. So I could write this as negative infinity, which gets a parenthesis, to negative 2/3, which is not included. And then I've got negative 2/3 all the way to positive infinity. And we can join these with this symbol right here that means union. It means we're bringing them together. So this is how we'd write it in interval notation. Let's take a look at example 2 and change color. So for problem 2, I have f of x equals x plus 6 divided by x squared minus x minus 6. So I'm going to take my denominator, and I'm going to go ahead and factor it. So I want to find the factors of AC that add up to B. So AC in this case is negative 6. The factors of negative 6 that add up to negative 1 are negative 3 times 2 and negative 3 plus 2. This means this will factor to x minus 3 times x plus 2. And we go ahead and set this equal to 0. Now we use the zero factor property to take each of those factors and set it equal to 0. So I get x is 3 and x is negative 2. Note, this is not my solution. This is the values excluded from our domain. Excuse me. So I'm going to go ahead and write that in in set notation. My domain is all values of x such that x doesn't equal -2 and x doesn't equal 3. This would be in set notation. For interval notation, we need to envision a number line. So let me think, what values are excluded from my domain? Well, it's -2, I'm going to have a gap there, and +3. But all other possible x values are in my domain. So this would be from -infinity to -2, together with from -2 to 3. Again, we use parentheses because our endpoints are not included. And we union that with 3 to +infinity, right? Because that's all the way over here. And infinity always gets a parenthesis. In the homework, it will tell you specifically whether to write it in set or interval notation. On an exam, I will ask you to do both once, so I know that you know how to do both ways of writing the domain.